Okay, because we have three panelists today, I'm going to go ahead and get started. And as other people come on, if you could just put your name and affiliation in the chat, we'd appreciate it. Welcome to the CRC Roundtable, our monthly virtual seminar series. Our intention, as always, is to host targeted, inclusive, and informed conversations that match scientific advances and management needs. The webinars are designed for contribution, not consumption. As a reflection of that intent, the panelists have been given about 25 minutes total to make some introductory remarks, allowing 30 minutes for discussion. And this is all about giving us a place to ask clumsy questions and to practice the bravery and humility necessary for going into the future. Let me start, as we always do, by just understanding why this topic at this time by these speakers. The diffuse nature of solar energy necessitates that large swaths of space or land be used to collect and concentrate solar energy into forms usable for human consumption. And that certainly increases concern over potential adverse impacts on natural ecosystems, their services, and biodiversity. The conflict has become front and center as we accelerate efforts to meet our climate goals. The United States may produce as much as 45% of our electricity using solar technology by 2050. And estimates of the amount of land required range widely, with an upper estimate I've seen being about 40,000 square kilometers, or roughly the size of Maryland. In Virginia alone, there are 140 permitted sites and 150,000 to 350,000 acres in Virginia projected to be in solar by 2045. To highlight the potential conflict in just one dimension, I'll just mention one study that modeled the results of 5 solar development scenarios through 2050 and potential impacts on animal movement. Across those projections, 27 to 33% of total solar development is expected to occur on land with high value for climate change induced migration. So I think that's just one example of the sort of trade-offs and conflicts we're going to talk about today. Our speakers today represent different dimensions of this conflict. Lauren McPhillips looks to inform policymaking related to solar energy by addressing how to minimize that very conflict that can occur when placing solar energy installations. Ryan works to gain a full understanding of impactive practices by quantifying and scaling interactions between water, soil, and plant communities. Mike Rolband is one of those rare individuals that knows both the on-the-ground realities of stormwater and construction projects from years of environmental consulting, and now works on the potential of policy to direct those actions for Virginia DEQ. With that, I'll let our speakers take the floor. If you haven't been here before, the 30 minutes of discussion, I'll facilitate both out of the chat and from the list of questions that were submitted ahead of time. So please, when we get to that point, feel free to enter your questions in the chat. We strive to answer as many as we can during the roundtable, and those that we don't get to, we send to our panelists afterwards to answer. So with that, I believe Lauren is going to start us off, and the floor is yours, Lauren.
Thank you so much for that lovely introduction, Denise. You make it so I can speed through some of my introduction because you set up the challenge so well here. So I am here to kick us off in the role, not just from my understanding of this area and some ongoing research in this realm, but because I also led a workshop sponsored by the CRC Science and Technical Advisory Committee that tackled this very topic. What do we understand about best management practices to minimize impacts of solar farms on landscape hydrology and water quality in our region? And so I'm going to give you a quick overview of some of our key findings there. So Denise already made the case of this rapid expansion of ground-mounted solar, utility scale solar in our region, which we need to reduce our carbon footprint, but we want to understand the implications of this process and what are those best management practices and making sure we're motivating their implementation. So thinking about potential impacts on the environment and how we can design to minimize those, we are adding impervious surfaces that are, designed to intercept solar radiation. So beneath them is going to be shaded. These impervious surfaces are also intercepting precipitation. And so on the water side, we have this instance where we're rerouting water around the landscape and redistributing it. And so what is the implication of that on runoff, on ability of vegetation to establish, and how do we ensure that any impacts that might exist are minimized? So in this workshop, we kind of started by setting the stage. And so I want you to understand too, some of the aspects we're understanding about how solar farms have been developing in our region most recently. And so Michael Evans of Chesapeake Conservancy has done some really awesome work that he presented about. And I give a snapshot here that showed not only the expansion of solar farms in our region, but the types of land that we are converting to this new land use. So his work looking at aerial imagery and remote sensing has found that solar farm development is preferentially occurring on non-natural lands, as in not wetlands, not usually forests, mostly cultivated lands, crops, pasture, and developed land that is still open, generally lower slope land. And for the cultivated land, it does tend to be more lower ag suitability. A big part of our workshop was to understand the state of the science. So what do we know about potential impacts and best management practices? We, as part of the setup for the workshop, we actually did a literature review of the published scientific research and found that there's very little out there. It is rapidly growing. So even in the couple of years since we published this, there has been, new work coming out, but really not much in our region. There's really a need there. And we'll hear about some of the newer work happening also in our region later in this session. This paper is open access, and so we'll get a link in the chat if we already haven't. But generally speaking, the existing work showed variable potential for impact. Some, solar farms very early on did have some demonstrated impacts on soil properties, causing some compaction. Some didn't really show big impacts on soils. Not really much work had looked at the hydrology side, though. Some evidence of redistributing water, but not a great understanding of potential impacts on runoff specifically. We did hear as part of the workshop, though, some cutting edge improvement in how we can represent the hydrology on solar farms. And so there's been a Department of Energy supported project called PV Smart, which worked to create a sophisticated hydrologic model to represent this very unique land cover of solar farms. And they basically took this sophisticated model and made it into a tool that would be very user-friendly. You can get it from their website. It's an Excel-based tool. And it can basically, you can put in information about the site itself, but also about the setup of your solar farm, like what is the proposed panel spacing, and understand, are there potential changes to the runoff? So engineers know of the curve number, which represents likelihood of runoff. So is that projected to change versus, non-solar farm condition, or is it, going to be similar? And so this tool is certainly very valuable, but it hasn't, was not tested like on some of the more complex sort of topography in some of our region. And so there's still some opportunities there to understand how well it works for some of the complexities of our region. Just getting to some of the kind of takeaways out of the workshop in terms of what we understand to be some best practices. It's clear that we need to be incentivizing selection of optimal sites for solar implementation. We're talking today more about these ground-mounted solar farms, but clearly there's a need to incentivize more leveraging of existing impervious surfaces, and also putting solar farms on more marginal lands. This could create challenges with runoff, but these are solvable challenges if we have the right structural practices in place. In Pennsylvania, brownfields, reclaimed minelands are becoming an increasingly implemented area for solar farms. Something that is really, really becoming very apparent is the importance of maintaining soil health through the construction and operation of these sites. And we'll hear more about this, I think, from Mike soon, but some of the challenges with the need to minimize soil disturbance in these sites to preserve that existing topsoil, to prevent the removal of the valuable topsoil as much as possible. Implementation of appropriate erosion and sediment control during construction and the oversight to ensure compliance. That image there previously provided by Mike is an example, one of the worst examples, but it is one that has existed. And so we need to do our best to ensure that the best practices are being used here. And then after, as the construction is moving towards completion and we're into operation, facilitating rapid establishment of perennial vegetation, not just for the runoff management and erosion reduction benefits, but also thinking about these other co-benefits. You see a snapshot from a solar farm here at the edge of our Penn State University Park campus that had this very vibrant, diverse perennial vegetation that could also provide pollinator habitat, not just these other soil and runoff related benefits. Just some of the best practices for post-construction management in our region, noting that the specific guidance varies by state. In general, one of the most important things for runoff management on these sites is having this disconnection of the impervious space. So having this space between the panels that is pervious with well-established vegetation is critical. So having a space that is, equal to or greater than the panel width to allow infiltration, having adequate vegetation cover, having vegetation growing under those panels, so shade-tolerant vegetation, and reducing mowing to just what is needed, or potentially leveraging solar grazing, which is something increasingly of interest. And just wrapping up my comments here with a little bit of mention of some of the recommendations out of the workshop. There's clearly a need for continued on-the-ground field, but also modeling-based research that can help us understand region-specific best management practices and making sure that they're practitioner relevant. As I mentioned, testing and customizing, if needed, the PV Smart tool for our region, just making sure it really does work, especially across the wide range of topography and geology that we have in our region. Considering how we might represent solar farms in the Chesapeake Bay model with this very wide range of land uses that may be transitioned to solar farms. And finally, it's clear that we need to continue doing better with information sharing. This workshop is one of those opportunities, but we'd like to do better in that realm as well. And so the last thing I'll just mention in the space of getting information out there, our university extension staff is really one way that we're trying to get information out there to the community. And so one example is Penn State will be offering a workshop tomorrow through our extension on solar ordinances in Pennsylvania, which I know is of interest to some of you. So with that, I'll pass it on to Mike to tell us some more.
Thanks, Lauren. Mike, you have the floor.
Thank you very much. That was a great introduction. I am going to talk about regulatory issues in Virginia, and I'm having a hard time getting my thing to there. It's okay. So to follow up in Virginia, what we're looking at from a regulatory standpoint is we have 6 major issues that we're seeing across the scape of all the different solar projects that DEQ is involved in the permitting world. We review both stormwater management and erosion control. Sometimes it's in conjunction with the locality. It depends on our system. We have 155 localities where they do the stormwater management, but they follow our regulations. So the first thing we're seeing is basically the soil structure is being destroyed on the majority of the sites. People are cutting and filling topsoil to grade the site. We'll talk about why they do that later. And then they're compacting the soil. So the runoff characteristics have changed, yet the stormwater management calculations are all based on the original pre-disturbance type of soils and characteristics. Second, we're seeing a lack of vegetative cover. And Since 1992, DEQ and its predecessor DCR has a regulation in place that requires within 7 days of reaching the final grade that it be seeded in straw with a permanent seed mix. 14 days if it's a temporary, it's going to be disturbed later, and that's just not happening. So the next couple of problems, this is listing, control maintenance obviously is a big problem, installing the controls correctly. And the last thing is a total disregard for natural drainage divides. So we have a regulation that you're not supposed to substantially change the drainage characteristics of a watershed, but we're seeing sites where they're eliminating a drainage area and increasing them by as much as 500%. So obviously it doesn't help the downstream property owners. This picture you already saw before in Lauren's presentation. This is, I call it the poster child, but unfortunately we're seeing this throughout Virginia. I mean, the last time we did a bunch of inspections on solar sites, roughly 70% of the sites looked like this. And the majority of the pictures of solar sites that we see in newspaper articles are denuded with panels. And the problem is before the piles are driven for the panels, they've reached final grade and they're supposed to have seeded and mulched it and started to get some vegetative growth. And it's just not happening the majority of the time. So this is a continual problem. These are a couple of pictures of other inspection sites, the air photos from a newspaper article. People are proudly talking about the completion of this solar project that has no vegetation. So it's just a fundamental problem we're seeing, and not having the vegetation when it's the stormwater calcs assume it is vegetated, plus the compaction means that the volume runoffs are way greater, and often the control systems are blown out. Another problem we saw last winter is it was rained a lot for a while. We had muddy clay sites, so people used quicklime and to dry up the sites to work on it. Fantastic. They can build anything on top of that, like a parking lot. And they created basically concrete, and they had runoff curve numbers effective of 98, like a pavement. And all the stormwater systems blew out because the runoff is way greater. They couldn't get grass to grow because the pH is 10. And so it's just another continual problem. Oops. So MS1, minimum standard number 1, that's the standard that we have in Virginia. And believe it or not, it's been in place since 1992. It's just not being followed. So we're doing our darndest now to really bring attention to everybody through newsletters and through inspections that we're serious about it. I've been told to my face by some consultants that the reason people don't do this is because it costs money and DEQ isn't enforcing it strongly enough. So we're trying to make a point now to enforce it. So one solution is to reduce grading. Last week in Environment Virginia, Novatos is a provider of a tracking system that won the governor's gold level excellence award for a site outside of Winchester, where they're using their tracking system, which uses basically universal joints in the bearings on each pile that can flex, okay, can rotate. Universal joints are typically used, for example, for at least 120 years in cars and trucks in the drive shaft. So they can follow the natural terrain. And the site in Winchester had no lane disturbance except where they put the trenches in for the wiring systems. So that's one way where you can preserve the soil characteristics, preserve the profile, and actually reclaim the site later on for farming practices or other uses. Whereas in these sites that are graded, compacted, and buried in topsoil, they're never going to be a very productive farm. This is just a picture of that field trip and the close-up of the actual U-joint that's on that bearing, so you can have that flexibility. They have different versions. And other manufacturers have told me they can do it. There's just not been a big demand. There's a white paper on this particular site, and the contractor told me verbally that they saved $4.3 million when they netted out the earthwork costs and the fact that all the piles can be the same length. Another thing that we put in our stormwater handbook that is effective July 1st is to reduce the runoff by using a rain sensor in the weather stations. So we basically, you have the ability, every solar site has a weather station. They go to what they call wind stow position, so they don't have a aerodynamic issue in high winds over 30 miles an hour. You can also rotate if you have a certain amount of rain. So that would reduce the impervious cover when you're looking straight down. And then once you're under 30%, you can have a further reduction for unconnected stormwater runoff currently in TR 55. This is a way to, we've on one hypothetical site of 20 foot on center panels, or 30 foot, 10 feet between the panels. They took a 50% impervious cover and effectively reduced it to 8% with a 60% angle with the two multipliers. So it can, theoretically, this should reduce runoff, immensely. The land cover conversion is another big issue. So House Bill 206 was passed in Virginia. Delegate Weber passed it, or was the patron of it, and it's proposing regulations on impacting more than 50 acres of contiguous forest and more than 10 acres of prime farmland. That regulation, we had 2 years of two different, a big group of 90 or so people, a regulatory advisory panel, and then a smaller group last summer. The regs have been drafted. It's in executive review right now. I'm hoping it'll get released soon. Our goal is to get them out and for public comment and maybe effective by the end of the year. That's our current goal. And obviously it's a contentious issue, but there are large amounts of forest land being clear cut and replaced with solar panels. Some people advocate that that's better for the environment. Obviously, some people advocate the opposite. And of course, the farmland, I saw there'll be lots of questions about it. But the idea is to push solar development to areas that have less impact on high quality farmland. And there's a lot of mitigation proposed in these areas as well, which basically is trying to preserve the soil.
You have about a minute, Mike.
Yep. And my last slide is the other thing we're doing is, there's a lot of debate over what's the proper way to model solar runoff, both quantity and quality. And some of the methods that Lauren mentioned, many people feel are not applicable to what we're seeing in Virginia. When I talked personally with the researchers, the PIs on that, they actually flat out said, well, first of all, you can't just change the soil profile. You shouldn't be compacting and grading and filling. So our model doesn't apply to that. So that was the engineer that set up the meeting was trying to use that as an example of why they can do what they're doing. So they got shot down, but we don't know the right answer. We're using current technology or current models, primarily Tier 55. So we've given a $3.4 million grant to Virginia Tech and Virginia State University to basically do this research. The goals are measuring water quality and volume, comparing to the current design practices, and try to improve the modeling so that this industry could continue to move forward with more precise modeling methods. They've gotten so far about $500,000 from industry partners as well. Hopefully they can get more resources and expand the scope of the research. With that, I'm going to turn over to Ryan Stewart.
Oh, thanks, Mike, and great pictures, really illustrative. And Ryan, the floor is yours.
All right, let's see if I can get the right screen. I think it's this one. Hopefully you see big screen. Okay, perfect. Well, thanks, Mike. And so I'm going to get a little bit more in the nitty-gritty of that study that Mike just mentioned. And as far as I know, this is one of the biggest studies in terms of scope and time of monitoring that exists for what happens to the hydrology in the soils after people install these large-scale solar installations. So our questions, I kind of boiled down to first, how do these utility scale solar installations affect the stormwater quantity, quality, and we're really focusing on nitrogen, phosphorus, and sediment, and the underlying hydrological processes. And then thinking about that development and revegetation process, what are the effects on soil quality and soil health, like Lauren mentioned. Thinking about this from the modeling perspective and the design perspective, are the current methods that are being used appropriate? And if not, how can we use the data that we're collecting to improve those tools to better match what's actually happening on the ground in these developments? So our experimental design is to choose 6 large-scale sites across Virginia. I'd say another difference between our project and the PV Smart is that we're working on sites that are an order of magnitude larger in terms of the area and the megawatts that are being produced on them. Our sites are on the order of 500 to 1,500 acres, 50 to 150 megawatt kind of range. We're trying to capture the different physiographic regions of Virginia, and we basically broke this down into some of the sites are going to be fully developed, built, revegetated, stabilized, And then other ones, we're going to try to get that transition from pre-development all the way through development, like we see in this photo, that we're trying to get that transition from undeveloped through the development process and then fully stabilized after that. And that's part of having the 6-year time frame to try to collect these data. And each of our sites, we're instrumenting both catchments that represent areas that have been or will be developed with solar panels, and then we have external reference controls that exist outside of that footprint of the solar panels. And this is just a couple of examples of the scale we're working at, where we're picking smaller subcatchments, 5 to 50 acres, that again, with and without solar panels being put in. I think Lauren's figure kind of early on showed that what does a reference condition actually look like, and these are very varying land uses that we see that are pre-existing and being converted into solar. And that's one of the things we're trying to work through, is how do we best represent these oftentimes mosaic or patchwork land uses that exist on these large scale solar sites that are going in. An example of one of the sites that we are started working in that's not yet been developed is we're picking, again, 3 subcatchments, and you can see here they're pretty different even in their pre-development state of being. And these are actively managed lands for the most part. These are lava-like pine plantations that have been harvested in the last 5 years or so. And so it's not like these are pristine landscapes. We're seeing compaction and ponding issues happening even before the solar panels are going in there. As Mike said, a big focus here is on trying to measure the runoff itself. So we've been putting in a variety of flumes. If there's constrained flow through a culvert, we've been using what's known as a Palmer bolus, which is shown on the bottom left. And then otherwise, if there's just a ditch or some kind of conveyance, we're putting in H flumes, which are shown on the right. And at each of these points, we're putting in a refrigerated water sampler that automatically starts pulling stormwater and collects a volume-weighted composite sample during the storm event that we have to rush out then and get and do the analyses on. Here's kind of the example data that we are collecting. One of our sites that's in solar panels. This was a tropical storm that happened last September. And we can see the hydrograph here. This is water coming off of the solar panels themselves. And that's really our emphasis, what's going into any stormwater ponds or other BMPs that are being built onto these sites. We also are getting some data on what's leaving those stormwater retention ponds as well, just to see if the design criteria are appropriate. We've been spending a lot of time and effort on characterizing the hydraulic properties of these sites, using surface infiltration, borehole permeameters to get at the subsurface properties. And I have a student who's been doing a lot of ponding measurements using these handmade gauges that measure what the ponding looks like across these different sites. Here's an example of the scale we're working at. Okay, on the left is a subcatchment, and these points represent sampling points that are laid out across the different soil mapping units that exist in that subcatchment. And then on the right is just the example of our ponding measurements, where we're putting out this grid every 100 meters, having these gauges and trying to get a sense of what the spatial variability of surface ponding and how that might lead to surface runoff formation. Here's just some example data on surface infiltration. This is what we're actually measuring in terms of water infiltrated versus time. And I put this in here just to get a sense of the variability that exists even before these panels go in, that it's not just one value. And that's part of the issue of why we're working at such scales, to try to better characterize this. And we can take data like that and start getting at what the hydraulic conductivity is, which is again an important factor in terms of infiltration runoff characteristics of a site. Here's just some examples of that ponding measurements. So it's a very simple system, manual. You just basically, there's cork inside the crest gauge. It floats up to however high water is ponded up on the surface. And then we just go out and read what that ponding height looks like and start to interpolate what that looks like between gauges. We've been doing lots of augering and pulling up samples and starting to characterize the soil properties there. And really the overall goal of all this data collection is to go back and look at the stormwater model. So this is just an example of calculations that's being used during the site development process. In the bottom left is a stormwater pond and the ditch feeding into that. So are these ponds appropriately sized for the storms that are being predicted? Are they capturing those runoff, the curve numbers correctly and things like that? And so getting, again, more on the ground detail of what these hydrological processes actually look like after solar development. And Lauren had a couple examples or a couple of notes on best management practices. Dr. Lee Daniels and I have also put together a white paper that's publicly available that talks about some of our recommendations for BMPs that people can use when they're developing and managing these utility scale solar sites in Virginia. So be sure to check that out. And I'll just thank you for your time and give it back to Lauren to talk a little bit about what some of the work they're doing in Pennsylvania related to this.
Thanks, Ryan. Lauren, you can take us home.
All right, I was getting a little lag there. I think we're finally up. Thank you so much. This has been wonderful to hear all these overviews, and I'm just going to bookend it here with a quick wrap up on some other ongoing research. So not quite as extensive as the awesome Virginia work happening, but we have some work happening still in central Pennsylvania, especially on these more challenging sites that characterize a lot of our state, a lot of rolling topography, karst, rocky outcrops to deal with. And these marginal lands are where we want to be supporting more solar farm implementation as there's, growing concern over focusing so much development on the more prime ag land. So, just a snapshot of some of our ongoing work. You see images of a few sites there with some rolling topography, and we're trying to answer a lot of similar questions that Ryan's group is. How are these panels altering natural hydrologic processes? Under what conditions is there runoff generation? When can we rely on that, interspace between the panels to be enough to infiltrate versus when is structural stormwater management needed? And so we are also measuring the function of some structural stormwater management. We have infiltration basins or trenches at our sites. And so we see that, they're able to manage the stormwater runoff in most cases, but these are things we're working on documenting and thinking about how we can manage the runoff in ways that's also generating those other co-benefits. And so we have some ongoing work here that's supported by Pennsylvania Department of Ag, especially to think about supporting more solar farm implementation on marginal landscapes. And so this is a combination of field and modeling work, a lot of the similar things you heard Ryan mention, looking at the soils, also a little bit of understanding of the vegetation, height and distribution, understanding how evapotranspiration and solar radiation changes and how that affects runoff generation. And we too are tying this all into understanding how we can improve modeling and thus design of any management practices. So that was my very quick overview, and we're now going to call it a wrap and open it up to questions.
Well, thanks, panelists. That was wonderful, actually, and a lot of information in a short amount of time. I'm going to start off with one that came in beforehand, and then we've got a couple in the chat. And for people in the audience, please enter your question in the chat. We try to get to all of them. And so the first one, Lauren, since you bookended it, I'll give you a start. We had a lot of questions actually about more specifics on solar development on agricultural lands and how that impacts soil health. Are there ways to counter that? Can we revert? I believe Mike kind of answered that question, but you can weigh in too. And are solar panels potentially less impactful land use than ag or suburban development on soil health? So general questions around soil health and the impacts to that.
So I think you've probably gotten out of the images and discussion you saw already that there's a very wide range in what's being implemented on the ground. So our hope is that these sites could go back to agriculture in 30 years at the end of the lifetime of their generation of renewable energy. But, some of these sites with removal of a lot of topsoil, challenges with getting vegetation established, there are potential issues with the soil health there. And so if we want to achieve that goal of being able to easily revert to agriculture without a lot of restoration needed, then we do need to do what we can to ensure these best practices are managed. And we heard a bit from Mike about some of the work they're doing to try to motivate the use of better practices and reduce these impacts on soil health. in terms of what is the relative impact of solar versus other types of land uses, either agriculture or suburban development. Any of these things could have a wide range of impact, right? Agriculture, we could be, doing agriculture more regeneratively and actively, maintaining or improving soil health. Or we could have, high intensity monoculture with lots of nutrient inputs that is, causing some negative soil health and negative water quality implications. And similar with suburban development in terms of the management practices that are used. So, we are building something on the land here. There's the potential for impacts, but, we have a lot of management practices at our disposal to do our best to minimize those practices and maintain the health of the soil.
Thanks, Lauren. Ryan, do you want to add anything to that and more specifically about what your modeling may tell you about certain effectiveness of the range of BMPs you've got?
Yeah, I mean, certainly that's one of the goals. And I think, as Lauren said, the vegetation is really key here. And I think we could even go back to the NRCS has their 4 principles of soil health. Keep soil covered, have living roots, maximize biodiversity and minimize disturbance. All of these things can be done in solar panels, like the picture behind Lauren shows a lot of those traits being done there. So I think that's one of our questions is what's happening on the ground, and if people are doing some of these things, what are the actual implications for the soil quality and soil health that's happening? So both measurements and then extending that to some of the modeling and thinking about stormwater and water movement through these profiles.
Mike, can you answer from the policy side about any upcoming policy or things to incentivize sort of maximizing how these things all fit together?
So from a policy standpoint, our House Bill 206 regulations are going to definitely encourage people to do the right thing in terms of, if you don't, you're going to have a lot more mitigation when you impact prime farmland or forest. So it's obviously it's a stick with a benefit in terms of, if you are building on these types of areas, but you do practices that mitigate the impacts, you don't have to do much in terms of mitigation. But if you decide to do it the traditional way right now, which is the grading and compaction, you're going to do a lot more. We also already put out guidance that if you're cutting and filling, compacting the soil, you're going to have to use a higher runoff coefficient. So right now, people are using the same coefficient of the undisturbed soil. We have multiple methods that they can go a simpler way or a more complicated way, but they're going to have to account for that in their stormwater management practices. There's been several questions about why not putting things on rooftops and parking lots, and that's, we're just a regulatory agency, and the issue is a financial one. I personally got, probably 10 years ago, I put solar on my rooftop of my old company building, and I put it on rooftop and ground mount in my farm. It was basically almost twice as much money to put on the roof.
Really?
And yeah, it was a lot of money. But so that what's driving people is the cost. So that would be more of a grant program or a tax benefit type situation to change people's behavior. But the problem is, when you're putting in parking lots, you've got to dig up parking lots to run all the wiring or run them above head, above and overhead, and you're disturbing the parking lot. You're going to repave it. You're doing it on a rooftop. If the roof isn't new, you have to replace the roof, because these last usually 25 to 30 years before they need to be replaced. So you'll need a new roof. And then there's all those associated costs. So, we're doing the best we can with our regulatory program by trying to set up incentives in terms of avoid these highest value areas. But if you don't, then you're going to have to do mitigation.
Mike, let me follow up with a question in the chat, because it's too cost related. It said, for the all-terrain trackers, is there a reason the solar industry hasn't more collectively taken on this mechanism that seems like a win-win? Saves significant cost and heavily decreases pre-construction compaction and associated runoff.
So I think it's going to start. I mean, I started preaching this when I came here 2 years ago, and I didn't even know that this company existed. I just know you could easily make this device, and do this. And it turned out there was some company that existed. The guy was at Black and Veatch doing solar projects and said, this is ridiculous what we're doing. And so it's taking some mechanical engineering to one component versus civil engineering. So what we had is people were sitting in their little silos, and civil engineers, I'm trying to create sheet flow and the panels have to go east-west. So therefore I need to grade the site. Whereas this guy was a mechanical engineer. So, well, I could just have universal joints and go up and down and not have to grade the site and save money. So it's starting to happen. They're growing dramatically. The two major trackers companies that I talked to about 1.5 years ago now, well, maybe 2 years even, they said they could easily do it, they think, and they know of another company that does it. They didn't tell me the name. And but it just hasn't been a big demand. I think you're going to start seeing that, unless you're going to a flat site. On a flat site, you don't need this. But what's happening is a lot of these projects that we're seeing with all the problems, the problems are occurring on sites that are being graded because they're not flat. And then it's happening when the panels are flat and you have a big storm event. If in the morning or in the evening, or overnight, where they stay in this one place, that they're at an angle, there's not as much runoff. So it just depends. But the more companies have been hit with the economic consequences, there was a lawsuit, for example, in Georgia, that was over $100 million award to a downstream pond owner from all the sediment from solar runoff. There's been a couple other court cases going on. There's a couple of contractors being sued by solar developers right now in Virginia. So as those externality costs are being conveyed back onto the contractors and the developers, I think you're going to see a change, but it takes time.
Let me ask a question, and probably first maybe to Lauren or Ryan. Is the modeling tools that are available, could that support a very specific sort of siting approach? Or, are these kind of coming up where a site becomes available and you have to sort of model and say, well, this is the potential issues and this is how to mitigate them. Is there the possibility of taking a more proactive approach to siting?
So we certainly can think about better optimization, but part of the challenge, there are a lot of factors, and some of them are things like proximity to the electrical interconnection. But then, also some of the land that's least likely to generate runoff is nice land that's great for agriculture, right? And so this is why we want to do better with the runoff modeling, so we can actually use some of these marginal sites, but make sure that we're doing the right kind of stormwater management, because those sites are going to be more prone to runoff. We have a lot of steep sites in Pennsylvania. We have a lot of poorly draining soils. We actually have a solar site in an active floodplain that's relatively new in Pennsylvania. And so our DEP is working to figure out, how can we support solar in these areas that aren't as good for other uses, but make sure that it's done in a way to minimize the impact there.
Ryan, I'll just note for people that aren't watching the chat, Ryan's gotten a lot of questions about sharing his data set, and he seems to be very gracious about answering that and saying he'll get it out as soon as possible. But Ryan, do you want to say anything more about your data set and add anything to Lauren's comments?
No, I think Lauren's right on in terms of the considerations. It seems proximity to power line and land availability. I mean, a lot of these companies are either leasing for 30 years or purchasing the land outright. And so I think they're looking large tracts that they can develop. Within that, I mean, once they've picked the site, I think that's where the tools can be used in terms of, like Mike said, respecting the natural drainages and trying to not grade things out completely so that there's large connected sheet flow or anything like that happening. So that's where the modeling can come in and just do a better job of, sizing any retention ponds and drainage conveyance networks and things like that within the sites, and just making sure that they're going to be adequate to capture what we're seeing in terms of precipitation now and what might look like in 20 or 30 years from now in the mid-Atlantic. Yeah, in terms of data set. Oh, go ahead.
No, you go.
Yeah, in terms of data set, I mean, our plan is this is funded by DEQ, so it's publicly funded data. So, I mean, we're kind of balancing the industry partners and making sure we're not giving away trade secrets, but they've all agreed that eventually that we'll go through the QA process and then share this data with DEQ. And from there, I definitely want to get it out there because I think there's applications not just in solar, but large scale hydrology in this region in general.
One thing I want to add about these practices, if you go to northern New England, you'll see a lot of two-way trackers and minimal land disturbance and very minimal effect on runoff. But energy prices are much higher up there, and there's a lot less sunlight available. So the economics of the extra cost of a two-way tracker is offset by the extra production of the power. The other issue is economics, because the power companies have a lot of pressure to keep the electric rates as low as possible. And a lot of people don't want to pay more money on their electric bill. So that's another pressure that we're not regulating, and the FCC regulates that. But that is another offset of why don't you do all these other great things.
Mark Dubin entered a really interesting question in the chat. Agricultural journals and newspaper publications are carrying advertisements for promoting solar projects on pastures or converting fields to livestock pastures. Are you aware of LGU research on the impacts of solar panels on pasture productivity due to shading, soil compaction, etc.?
I was just starting to type an answer to this one just to say that, solar grazing is becoming a big thing, I think, both in Virginia and Pennsylvania. So, the use of sheep for managing the vegetation. And so then you don't have to mow, you're able to use the sheep to keep the vegetation from shading the panels. And then obviously you're growing the sheep and keeping some kind of agriculture in place. There are challenges with thinking with growing the amount of businesses that are able to, to do this, the knowledge to do this solar grazing, and thinking about, there's not as much demand for wool. And so I know there's sheep being used that aren't the wool producing kind. I've had some of these discussions as the solar grazers are trying to figure out how to make this market work for them. But it's definitely a really growing area of interest. And it does help people feel like the land is somehow staying in some form of agriculture. And the American Solar Grazing Association is really like working to kind of expand the understanding and the market there. I don't know what others have to add on that.
Yeah, I agree. I mean, we're certainly seeing sheep be a primary agrivoltaics kind of application. And I mean, there's some challenges, particularly early on, that if the vegetation is not well established, the sheep can, almost be a detriment. So again, comes back to vegetation and getting things well established and healthy. So yeah, I think there's definitely a lot more we can learn about how those land uses work in this region, but it's definitely an area of interest.
Let me just say that Norm Goulet entered that the Chesapeake Bay Program Land Use Team and Urban Stormwater Work Group is starting an effort to look at how solar might be modeled for water quality in the upcoming Phase 7 model. Mike, here's a wonderful question, I think, for you. Peter Claggett is asking, to what degree are data centers driving the rapid expansion of USS in Virginia compared to state climate mitigation plans or other factors? So at that state policy level, how are you balancing all that?
Well, the easy answer, Peter, is that's Virginia Energy's topic, not DEQ's. So we're not directly involved in that part at all. But right now, it appears to be driven primarily by the Virginia Clean Economy Act. The demand in terms of we have a certain amount of solar and wind that we have to get in place. And as you know, probably the land wind is not happening. There's only one proposed project, and it's been in litigation for almost 10 years, I think. The offshore wind the first project just got approved, the last federal permit a couple of days ago. But right now, the solar is being driven primarily by meeting the VCEA. But of course, it's pretty well known that a lot of the solar projects have been funded or with takeoff contracts by some data center projects as well.
Great, thank you. I'm
And
gonna,
I will say there's a JLARC study that's started last December that's looking at that as well.
oh, great, thank you.
Joint, yeah.
Lauren, I think I'll start with you on this one. Kind of a combination of a question that's in the chat and one that got submitted ahead of time. The one in the chat is, what other types of agricultural co-uses exist? Like, for example, bee farming entering the picture. And we had a question about, are solar fields a good location for pollinator gardens, or is there a problem with the runoff, the stormwater runoff and quality? So it kind of starts to get into not only quantity, but quality. So can you take a crack at that?
Yeah, certainly supporting pollinator habitat is another thing people are interested in. There's a less obvious like economic benefit and model there versus like solar grazing. Just unfortunate challenges in valuing important ecosystem services like supporting pollinator habitat. But there is, there are a lot of folks that are thinking about trying to use seed mixes that would support like a diverse perennial vegetation community that has, different types of flowering plants. I'll say, there's challenges with like existing seed banks coming back. This site looked like this a few years ago. It looks a little different now, some more thistle, but still, vibrant, diverse mix that's supporting a lot of insects. And some folks are studying those benefits actively. I know Cornell is actively engaged in that. I'm not sure about like active beekeeping on some of these sites, if that's a thing at all. But it's certainly a possibility. But in Pennsylvania, there is a seed company that has developed a fuzz and buzz mix, which has gotten popular to support both solar grazing and also pollinator habitat. I'll let
Buzz
others.
and Buzz. It's a clever name.
In Virginia, we DCR and DEQ have a pollinator smart habitat program that they're trying to promote pollinators in use on solar sites. I believe one is approved and maybe two are close to approval. They may have been approved by now, and they're primarily using a seed mix developed actually, same company, I'm sure, Ernst Conservation Seeds, and in Pennsylvania. Doug DeBerry, a professor at William & Mary, was the person that was primarily in charge of developing it in Virginia. But it hasn't gotten a lot of traction yet. And I think it's relatively difficult sometimes to get these native pollinator mixes to get going early on, and they've had a lot of invasive issues. And I know a couple where they're putting bees in and they have bee enclosures on the perimeter of the sites, but from what I hear, it's not exactly making a lot of money.
Ryan, let me ask you this question, because you're working at such a scale. It's a wonderful study because of the scale of your sites. But are you looking explicitly at maybe the trade-offs of solar development with forest and habitat loss, carbon storage, other ecosystem services?
Yeah, I mean, certainly there's a consideration. So those are not explicit goals of our project per se, but comes up all the time. Should be cutting down forests to be putting solar panels out there. Yeah, again, the ones we've been seeing so far, it's not like these are 200-year-old deciduous forests necessarily. These are managed pine plantations. So yeah, I think there's definitely opportunities to learn more about what that means in terms of the life cycle of the trees. That's not our goal per se, but be happy to team up with people that maybe are more interested in that question and see if we can make that happen.
We have about 4 minutes left. And so what I normally do is, and I'm sorry I didn't tell you ahead of time, but is just ask each of you for a sort of last comment, something you want to make sure that people are left with from your remarks. And so maybe I'll go to Lauren, since you bookended everybody. If you want to start off with a parting comment.
I think my main comment goes back to the first question we answered, which is just like solar farms can take a wide variety of forms, and we can do it right or we cannot. And so our goal here is like support the fact that we can have renewable energy and have practices in place that are, not causing net negative impact or maybe even regenerating the land from the prior land use. So our hope is that we can move towards that and hope to find a regulatory and economic model that motivates people to move towards those best practices.
So not only do no harm, but go a step above where it's regenerative as well. That's interesting. Okay, I'll go to Mike.
I think the one takeaway I would suggest is, don't disturb the ground, the soil. I mean, that is the key, and keep it vegetated, and the majority of our problems we're seeing won't occur.
Great. And Ryan, you're sort of the representative of what we know and how fast we're going to learn.
Yeah, I mean, I think how many people signed up for this event and how many people are showing up and asking these great questions just emphasizes the broad interest in this topic. So it's just really exciting to be part of the ground floor of what this process looks like in terms of solar development and the related environmental impacts in Virginia. So we're going to keep trying to get the right data and help answer how we can do this better and get maybe some of those co-benefits that might exist there.
Great. Well, I'd like to just thank our three panelists. That was an excellent view of a pretty complicated topic. I'll just remind everybody that all of the questions that were in the chat, all of the ones that are submitted beforehand, we go through them. We cross out the ones that were actually asked during the webinar. We give the rest of the list to our panelists to let them answer. We'll send out a compilation of those answers and a link to the recording in, I believe, a little less than a week. So thanks again to our panelists. Thanks again to our attendees to ask some great questions, and we'll see you next month for our next CRC Roundtable. Thanks, Mike, Lauren, and Ryan. Excellent.